All right. Welcome everyone. As always, what we'll do is a little bit of an introduction while we're waiting for everybody to join. So unfortunately, it is the final seminar this week. I'd just like to really quickly thank everyone who's been coming along every week and everyone who's been watching the recordings as well online. It's been really lovely to have you here. It's been really great to see all of your answers and all of your questions as well for the presenters. Um, so yeah, just really, really briefly, because I know nothing's really changed from the last few seminars, but just to outline the structure of the session, what we'll be doing today is that for the first half, we have Alex today who will be presenting, and during that half, you are welcome to ask questions using the Q&A. However, we'll only be answering questions that are directly sort of relevant to what's on the screen. So if it's something like a keyword that you don't understand, that's the sort of question that we would pick up. Anything else will wait until the end, where we have a dedicated Q&A section, and we'll be going through as many questions as we can, really. So yeah, what I'll do to begin, while we're still waiting for people to join, is we've got a really quick starter poll. So that should have launched for you now. Just two really quick questions. And the first is, have you attended all the seminars live? So this is, have you come every week rather than watching the recordings? And then the second question, slightly longer, is if you were at last week's seminar, what was the most interesting thing that you learned? So yeah, do take a moment to answer those questions. Hopefully shouldn't take too long, just while we're waiting for the last few people to join. Um, all right, so I'll probably give it another sort of 30 seconds or so. So if you haven't answered the poll, please do get your answers in. Yeah, so I can see we've had about 50% of you got your answers into the poll so far, and it looks like 70% of the people who've answered have attended all the seminars live, which is amazing. Well done. You should be really proud of yourself because it's quite a big commitment coming to every single session. Um, so that's really good. Yeah, well done. Um, and then we've got just under 70% of you who've answered. I will close the poll very shortly just so that we can carry on. So if you haven't clicked submit yet, do so really, really soon. In 10 seconds, I'll close the poll. So yeah, do submit as soon as you can. And then we'll have a quick look through some of your answers to the second question. All right, so I'll close the poll now. The final numbers are about 80% of you attended every week, which is amazing. That's really, really good. And let's have a look at some of the things that you found most interesting in last week's session. So someone just says super ionicity with lots of exclamation marks, how high pressure physics is used, how algorithms can generate new structures and the potential that quantum computing has. Learn about superhydrides, DFT, which is density functional theory. Yeah, so someone says that they really enjoyed seeing how computer science linked up with physics, learning about the basic concepts of quantum mechanics and learning how computers are used in science and physics. Let's see what else we have. How DFT calculations are used for modeling. Someone else talking about quantum physics and mechanics, the applications of superhydrides, and how models are used to discover them. Loads and loads of stuff here, which is brilliant. Yeah, thank you so much for giving your answers to that poll. So what I'll do now is I'll hand over to Alex to start her presentation.
Okay, hi everyone. I'm Alex. Great to meet you guys. I'm a second year undergraduate in Cambridge, currently studying computer science. Fun fact, I'm actually an international student. I'm originally from Singapore. And I guess what originally really got me into computer science was video games. For those familiar with video games, I was really interested in role-playing games in particular, which is basically where um, a game is kind of like a story where you act as like a character in. And I really liked how these games could create these really interactive and immersive worlds and how, all these people could seem so lifelike and in the process tell really interesting stories. And I really wanted to know like how algorithms basically translated into that kind of behavior from, non-player characters or from storylines, like how these stories could be told, which is very, very tangentially related to what I'll be talking about today. So I guess I'll just go right into it. Let me share my screen. Um, all right. So okay, I think it should be sharing now. So what we currently covering today is sentiment detection. Automated sentiment detection to be precise, about how computers can analyze emotion and it's in text and how this can be used. So slide. So first of all, what is sentiment detection? So let's pull up, for example, a movie review where someone says, I thought this movie was going to be great, but it's actually really terrible. I hated it, 0 stars. Did this person like the movie? How can you tell? Well, it's pretty obvious that they didn't like it. But when it comes to the internet, which has tons of this information, like millions of movie reviews, millions of other reviews, millions of texts from social media and from other sources, is it possible to have an automated system that does this for us, where they can tell whether someone's opinion of something is positive or negative? Basically, obviously, can we make a system to tell someone's sentiment towards something? So there are a few ways. And of course, as we go down the rabbit hole, there are only more and more complicated ways to do this. But for today, I'm just going to cover some fundamental concepts that people use to develop more complicated systems from there on out. So let's go really simple. The first way is the same way anyone learns a language, right? You use a dictionary or a lexicon, which is another word for dictionary. So so there are some key words in this sense in this movie review that we can kind of tell the sentiment from. So for example, great, terrible, hated, all these things are adjectives or verbs that kind of give people a sense of like how this person feels about something, right? Like great is positive, terrible and hated are negative. So just like how if you didn't know a word, you check it up in the dictionary, why don't we teach our system what these words mean in terms of sentiment by giving them a really, really, really long dictionary, which had a table of words and whether it was positive and negative. So maybe let's say we have great is positive, terrible is negative, excellent is positive, and then we keep going. So what our system would ideally do is scan every single word in this and check our dictionary and say that altogether there are a bunch of neutral words like I, this, movie, whatever, but there's altogether one positive word and two negative words. And then we can basically kind of convert this numerically and then say that, oh, we have an overall score of -1. And then since it's a negative, you can say, oh, this person didn't like the movie. So now I kind of want to pass it over to you guys. So here are some questions. So are there any cases where this system wouldn't actually work? Are there any assumptions? And are there any limitations? So I think there should be a
Yeah, yeah.
code about now.
So it should have just appeared, and it's exactly the same as the questions that are on the slide now. So yeah, do fill those in now, if you can, and we'll wait maybe 1 or 2 minutes, because we've got quite a few questions here. Yeah, and I should say, if you're not sure for any of these, you don't have to submit an answer to every single question on here. You can just submit an answer to the question that you want to submit an answer for. And I guess while we're waiting, there are a few questions that have just come in. So one person has asked, what happens if you get the same amount of positive and negative words?
That's a great question. So let's just go back to this. So Wait, nope. Oops, spoilers. But no, that's a very interesting question. So we are assuming here that there must either be more positive or negative, right? Which is definitely not the case. And the answer is just basically up to the programmer, right? And how would we, and in fact, the baseline doesn't even need to be, oh, you need more positive than negative. What about if we said, oh, we set the baseline to 4? So if the score is more than 4, it's positive, if it's less than 4, it's negative. We can't just pick this arbitrarily just based on 0 or 4 or 8 or -4. We should pick them based on data, and that's where research comes in, right? So I would say that the baseline is usually picked on previous research. So maybe, um, like, I guess how, like, one way to test this is that maybe if you had a data set full of a ton of movie reviews, and then the positive, negative, positive, negative, negative, where an actual person read it and labeled them. If we used our system and then generated our own predictions and then compared those, we could kind of see like, oh, maybe 0 isn't the best baseline, maybe 2 is the best baseline. So basically, yeah, it's basically up to the programmer. And that's why, so much research is needed. And this especially comes into play when it comes to more complicated models. Because in the end, all our models are based on the decision procedure, right? Where it's either, oh, it's positive or it's negative. But this all, once again, has to be based on data. That's how you make the decision.
Mm,
Uh,
absolutely. So what I'll say, we've had over 50% of you respond now. So I will close the poll in about 10 or 15 seconds. So if you're just typing, please finish up and submit your answer because I will be ending the poll. And then we'll have a look at some of your answers. And just to note, I've seen that there are quite a few really good questions in the Q&A box, which very much link to things that are talked about later in the presentation. So I'm going to hold off from answering those questions. But yeah, do just keep them in mind and they might be answered in a minute. So yeah, I'll end the poll now. And let's have a look at these results. So for the first question, we had, are there any cases in which the system would do really, really poorly? And we've got lots of answers here. The most common one by far is when the text is using sarcasm or being ironic.
I think that's a great answer and definitely true, right? Because if I just said like, oh, this movie was oh great. I really, really loved it. I mean, anyone who's hearing this would obviously say like, oh, okay, I'm sorry. But a computer won't tell that. And that's why in science fiction, tons of robots can't tell sarcasm, and that's a big problem because even now with really sophisticated tech systems, sarcasm can still be a challenge. But considering this is a really simplistic approach that only looks at the words, this is definitely a really big weakness.
Mm. I think another really, really good point that lots of you have made, I can see, is when words are used that have dual meanings. So, for example, someone has given the example of sick being a slang term, which can have like two separate meanings. Yeah, what would you say to that, Alex?
I think that's great. That's a very good point to bring up because there are tons language is always evolving. Like again, this movie is
Absolutely.
sick. New words get added to our daily vocabulary all the time, and even worse, words can change meaning, which means then it
Mm,
makes you start thinking like, who's writing this dictionary? How old are they?
mm,
And how often do they update it? So things like that.
absolutely. And we've had a lot of answers as well, people saying someone might just give a bit of a vague answer. So they might say something like, it's not terrible. Um,
Yeah,
so
I
yeah.
think that's also a really good point. I think this also really ties into what someone mentioned about how what should we do if the overall score is 0? Because positive and negative,
Mm,
these are really discrete categories where, oh, you must like it or you must hate it. But most people are just like, oh, that was okay.
mm,
It wasn't
yeah,
terrible. And of course, there are
absolutely.
different ways to solve this. If we stick with this very simplistic approach, we could always do the thing where, oh, it's positive, it's neutral, or it's negative. We can add a third category where they're just more borderline. So maybe like, oh, if the score is 2 and above, it's positive. If it's -2 and less, it's negative. And if it's in between, it's neutral. But that's also the very interesting thing because even as people, we will read people's sentiments wrongly. right? There's no,
Mm.
like, sometimes someone will tell me something and I'll actually think they mean something else. So yeah, that is true. That's a very big problem.
Mm. And then another problem that lots of people have mentioned is if the word not is used basically before positive words, for example.
Yeah. I think I might actually have well, never mind, I'll check later, but I
Mm.
think we do talk about this later about how, yeah, right now what we're looking at is that it highlights individual words. And we don't really think
Mm.
about what comes before because what I put here was actually an example. We say, I thought this movie was going to be great. It's not
Mm.
actually saying the movie was great. I said I thought it was going to be. So right now we're taking individual words out of context, which is
Mhm.
not correct.
Absolutely. And so I'll move on to the second question now. Yeah, lots of very good answers for the first one. The second question was, are there any assumptions made in this system? And the first one here links very much to what we just said. And the assumption is the good words will always be used in a positive context. And then a very similar answer here as well, that all words that appear in the lexicon are being used in the context that the lexicon expects them to. So this example sort of covers words that have a dual meaning. Um, Someone else says words have a fixed sentiment, which again is something that we've discussed. Um, all the words in the dictionary will be spelt correctly. That's not something I've considered, but that's a really good point as well, isn't it, Alex?
Yeah, I think the previous few assumptions that people brought up really tie into what we said about well, multiple things. First of all, sarcasm, things like sarcasm, vocabulary drift over time as like words take on new meaning. And also the fact that we take each word individually and we don't consider what's around it. All these three things really come from these assumptions that people mentioned. The very last assumptions was very interesting in terms of spelling errors. And then so what a very common approach would be in this case would basically to stack our system in layers, right? Because this current layer assumes that everything is spelled correctly, right? And we kind of want to keep this layer. It wouldn't we wouldn't really want to change this layer because it's already all nicely laid out. So it would make a lot more sense to put in an additional layer where we say, okay, we go through spell check first, and then we go through this. And then the spell check layer, of course, will be a whole different question of how do you know what they were intending to do? It'll be probably some sort of system of, oh, what keys are near each other? What kind of spelling errors are people like likely to make? What kind of words are most close to this? What kind of words would make the most sense in the context of the sentence? Which is a whole different question and actually would probably result in a whole different machine learning model, which I mean, text prediction is already a thing that exists and it's definitely something that runs off that. But yeah, that's a really interesting
Mm.
assumption to add.
Yeah, lots of other really great ones, which very much link to what we've spoken about already. So someone's saying here, the person isn't being sarcastic, the person has a strong opinion either way. Um, yeah, this is all, yeah, very, very similar. And yeah, lots of brilliant answers for that one. I will just move on because I'm conscious of time, onto the third question, which was what are some limitations of this system? For example, in regards to the lexicon the system refers to. Yeah, lots of different answers for this one. And one of the first is it's very hard to make such a lexicon. And another similar answers is it'll take up loads of storage space because it covers so many words.
I think both are great points.
Mm.
Um, Again, yeah, it'll take so much space, it'll take up so much time. And then we also need to start thinking about maybe like who will be doing the updating first of all, right? Because even among humans, there's a lot of subjectivity. Like how
Mm,
my favorite
absolutely.
example is if you say someone is a good person and someone's a decent person, how would you rank those people? Because I've met so many people who tell me like, oh, decent sounds kind of passive aggressive. Meanwhile, some people were like, no, decent is like they're not just good, they're decent.
Yeah,
And
yeah,
because
yeah.
of that, because of that, there's so much gray area that to have
Absolutely.
someone label this in the dictionary is already going to cause so much chaos. I think another really interesting point that I think people have been kind of nearing, but just to like put it out there, is that there are different levels of words. Like I thought
Mm,
this movie was good as opposed to this movie is great. You know what I mean? There's different levels of intensity. And you know,
absolutely.
Yeah, and this system can be extended in any number of ways. You can say like, oh, um, like we have a category, we have another category. It's not just positive and negative. Now it's also severe and not severe. And like a severely positive word is 4 points, while one is 1 point. We can extend this in any number of ways to make it more accurate. But I think what's really important to note is that there are still those underlying assumptions and limitations. Yeah.
Absolutely. Yeah. And so that's actually something that someone said, what you mentioned, Alex, is could we give some words a different value? Which you
Yeah.
just said we can if we want to. Lots of people talking about how um, when new words are created, you'll have to update the lexicon, which is a really good point. Sometimes sentences don't have clear meanings. They could be sort of jokes or references, which I think is a really good point. Um, so yeah, another really good point I think is that you would have to have sort of a finite number of words, so you'd have to probably limit it to one language, things like that. But yeah, loads of amazing answers, but I will have to finish there just because I'm, yeah, like I said, mindful of time. And I'll let Alex carry on.
Yeah, so I'm so glad Erin made tons of great points because you guys have basically done my next slide for me. Um, so this is some questions. Let's try it out. Yeah, we kind of already went through this already, but just to let people see, like, let's just let people see in action.
Mm,
Let's try it out. There are two examples here. We have one that says, this movie was so amazing. I had so much fun watching it. 10 out of 10 will go again. And then another one was saying, this movie was so entertaining that I couldn't help but fall asleep. I don't know how the director managed to make such a fun movie that someone had to physically leave the theater. Hope they do better next time. It was not good at all. So people have already started responding,
yeah,
and
yeah.
yeah, it's unanimous mostly, which is quite crazy. But I think this really demonstrates what we're talking about, right? Like, a lot of people mention sarcasm, and this is a great way to show it because there's nothing but good things in the second sentence, according
Mm,
to our system. But any human, as shown by the unanimous voting, can tell that it's
mm.
obviously sarcastic.
Absolutely.
Um,
And I think another thing to note that I think is a little bit interesting is that for some people, the
mhm.
first sentence they actually have rated it as negative, a minority, about 5% of you. Um, but I think that's interesting. That talks about that kind of links to what we spoke about when different people have different ideas of what language means.
Yeah.
And that's why it's so hard to make a sort of a lexicon that where you say this is all absolutely the ground truth. So that's yeah, it's really, really interesting. Do keep putting your answer in the poll if you haven't done already, but I will be closing it in about 10 seconds or so. So yeah.
Yeah, it's actually really interesting how we have like like a small minority, but a minority nonetheless. It really thinks about when we're when we're trying to make decisions of this data, it's once again best to go off what most people think, right? But then that also leads to limitations by itself. So I
Mm.
think that's quite interesting. Um,
All right, I will close the poll now.
Yeah, I think I'll move on as well. So again, everyone has basically said my limitations for me, but basically, what's first of all, using a lexicon, the sheer amount of time and updating in space is insane. Because people have been saying, oh, people can always have new words, words can always take on meanings over time. That means some poor soul is going to have to keep on updating, which is not feasible and not realistic. Another thing is that how it's static, it's not adaptable. Again, it relies purely on the lexicon. And the other thing is that how it treats each word independently. And I think this is very important because once again, this movie was not good. It doesn't take into account the not, we just see the good. And that's obviously a weakness. Um, so obviously many limitations. We want to try to use a more flexible approach. And I think what's really interesting about lexicon is that it seems to give a very objective answer, I guess, in a way, where it's the lexicon basically says, oh, this is positive. Why? I said so. What if we could use data to tell us that instead, right? So that's how a machine learning model comes into play. So now I'm going to be talking about a different approach, more, more sophisticated, still a bit simplistic, and we're going to talk about why, but that's for later, called a naive Bayes classifier. So a naive Bayes classifier is a type of machine learning model And before I get into it, I know you guys have done machine learning in the previous talks, but I'll just go through some quick definitions. So machine learning model basically takes in a ton of data and from there derives some insights about the data, right? So it takes in features, which is observable properties of data. So in this case, it will be the words of the text. It can assign them to classes, which is what insights we derive from this data. So we want to tell if this text is positive or negative. So in this case, the classes will be positive or negative. Of course, we can talk all day about whether they should be very positive, very negative, neutral, whatever. But for now, let's just stick to positive and negative. Classification is basically this function that maps features to a class. So we say, now that we have these words in this text, are we going to tell that this text is positive or negative? And a classifier is just a system that does this. So for example, a naive Bayes classifier. So, right, previously our lexicon was just saying like, oh, this is positive because I say so. But what if you could actually calculate the probability that a data belongs to a certain class given its features? So basically, the probability that the review is positive or negative given the words in the review. So for example, P positive type O. So just a quick intro to like what this notation is basically just saying the probability that the review is positive given O, where O is all the words in the review. So given that this word is all of these words are in the review, what's the probability that this is positive, right? And so basically our classifier is just saying, okay, if P positive given O is more than P negative given O, the review is more likely to be positive because of these words. And then our system would be like, okay, we're not sure because we can never be sure, but it's probably positive. And then vice versa, if P negative is more than P positive. Once again, if P positive equals to P negative, that is once again up to the programmer. That requires testing and that requires research for people to be like, okay, where exactly is our threshold? Let's keep going. Okay, so basically what we want to find. So what our classifier is going to do is it's going to return a class, either positive or negative, where it's equal to this equation here. So argmax is basically just saying, I want because there are two possible values of C, which is either positive or negative. So we're just saying, I want the class C that generates the maximum value of PCO. So basically, if P negative given O is greater than P positive given O, we want negative because negative maximizes this value. And then vice versa for positive. And I think what's really important here is that we're only returning C, basically positive or negative. We're not actually returning the probability itself. So the actual values of it don't actually matter. We just need to know which one is bigger. Bolded because this is going to come into practice later. So it's called naive Bayes classifier, right? So we're going to go into, so we've talked about why it's classifier. Now let's talk about why it's Bayes. So I think this might have been covered in A-level maths, but Bayes' theorem is basically something about probability, where you're saying that the probability of A given B is the probability of A and B divided by the probability of B. And then basically we do this the other way around. Oops, spoilers.
So yeah, really, really quickly, there was just a question about some of the notation.
Yeah,
So in one of
certainly,
the
sure.
slides, there was like a little hat symbol on top
Where's the
of
hat? Oh,
a
here,
C.
yes.
So what does that hat symbol mean?
Um, if I'm not wrong, the hat symbol can mean different things given the context, but in this case, we're saying hat C is our chosen C, like the estimated C based on our data. Hat in general kind of means like, oh, this is the estimated value for something.
Perfect. Thank you.
Great question. Thank you so much. Anything else before I go on?
No, nothing else.
Okay. But basically, yeah, so already went through this equation. This is basically just the opposite with A and B reversed. And then basically from this, we can say that P, A, and B is equals to P, B, or P given A multiplied by PA by moving the things around. And because of that, PA given B is P and B, which is this thing over here, divided by PB. So this is very important. Please keep this in mind because when we want to find PC given O, we can apply Bayes' theorem to basically move it around where we, instead of PC given O, we have PO given C multiplied by PC over PO. And so just a quick refresher, C is the class that the text can be, so either positive or negative, and O is all the words in the text. So the thing is, once again, I said that we don't only need to compare this value. We don't actually need to calculate it. And PO is going to be the same no matter what C is. If C is positive or C is negative, the probability of all the words in the text is going to remain constant. So because of that, we actually don't need to count this in our comparison. It's basically like comparing A divided by 2 and B divided by 2. You don't really need to compare the two. You can just say, oh, if A over 2 is smaller than B over 2, then A must be smaller than B. So we can basically ignore this and we just say, okay, we just need to calculate this PC and PO given C, which is P positive and negative and P all the words in the text given the class. So how do we get this?
So yeah, really quickly, sorry
Yeah, no
to
worries at
jump
all.
in. Just a few questions about the maths that we had on the previous slide.
Yes.
So we've had yeah. So the first question is, what does argmax mean?
Mm-hmm. Let me go back to the slide about argmax. So argmax is so okay, so max would basically be maximum, right? So where if you take in maximum A or B, you just return A or B given depending on which one's bigger. You return the maximum. But argmax, basically the arg stands for argument. So argmax is saying I want to return the argument that returns the maximum value of this. So I want to return C depending on what maximizes P C given O. Because once again, C is the class chosen by the system, so it's either positive or negative. And because, so that means for PC given O, we have two options. We either have P negative given O or P positive given O. And depending on whether it's negative or positive, one might be bigger than the other. So we return negative or positive depending on which one's bigger. So again, in this example, if P negative given O is bigger than P positive given O, we say, oh, the class negative maximizes PC given O, so we should return negative. And then vice versa.
Perfect.
I hope that
I think
clears it
that's a
up.
yeah, that's a really,
Yeah,
really clear explanation. Hopefully that does clear up. And sorry, yeah, just two more questions talking
no
about
worries,
this.
go ahead, yes.
So the first one is how do you calculate the probability of A and the probability of B, where A and B are different words?
Sorry, the probability of A and the probability of B, where A and B are different
Sorry,
words.
sorry, I didn't make that very clear. So it's probability of A
Mhm.
close bracket, and then
Okay.
separately probability of B. How do you just get those probabilities? Like how do you find the probability of A where A is a word? How
Okay, oh
does that
yeah, okay.
work?
Yeah, that works. I'm actually going to go to that in the next two slides. So if you bear with me, I'm just going to do that. And then if you have any questions about that, we can go back to it. So,
Absolutely. Yeah,
yeah.
that's totally fine.
So yeah, so again, as we said over here, wait, sorry, you said there were two questions. Is that it? Was there another one that's like
The next one's very similar, so we might cover it. I'll come
okay,
back
yeah,
to
let's
it.
let's
Yeah,
let's go through the first two slides first, and then we'll see where it goes from here. So once again, we need PC and POC. So once again, C is either positive or negative. O is all the words in the text given the class. So, okay, this is not going to answer the question yet, but very quickly, let's talk about the probability of C, which is the probability that any review, no matter the words, is positive or negative, right? And can we find this out for sure, absolutely forever? No, there's no way. But what we do basically is estimation, because what machine learning models do is they take massive amounts of information. IMDb has probably 1 million reviews by now. So they take all of this information and they basically estimate it. So maybe if we manage to sample a very large amount of data, some poor soul labeled all of them with their own eyes, positive or negative, then we can just estimate this. So we say, okay, P positive is probably going to be around the number of positive reviews divided by the number of total reviews overall. And the negative is just the same thing, but negative. And this practice of taking a sample, estimating it based on the data we have is called maximum likelihood estimation. This is the most simple version of it. There's a lot more maths that goes into it, but if you guys are interested, just Google maximum likelihood estimation and you'll get a ton of things. And then now this is more related to the question where it's obtaining P O given C, where O is all the words in the review. So here's the thing. The probability that all of the words in the review, which is O, given that the review is positive or negative, is impossible because we would basically use Bayes' theorem to say, oh, what are the reviews where all the words show up and divide that by the total number of reviews of class C. And that's impossible because all of these words happening together are never going to happen again, most likely, or maybe once if someone's really weird. So because like, for example, say we have a review that says, oh, this movie was great. We don't have a lot of data where this movie was great in its entirety appears. So we make an assumption. Each word occurs independently. So when it comes to independent probability, if A and B are independent, P, A, and the probability of A and B happening together is the probability of A multiplied by the probability of B. So we say that the probability that all of these words happen together is the probability of the first word given C multiplied the probability of the second word given C, and so on, so on, so on, until all of the words are done. So instead of the probability of this movie was great, given that the movie was positive, we say, oh, it's kind of similar to the probability of this given C times probability of movie given C multiplied by was given C and probability of good given C, where we break it all up into individual words. And because we're basically multiplying them we keep multiplying them. Another way of representing this where we say like, oh, we multiply like W1, W2, W3, we just express it as this. Like this notation is basically exactly the same as this. It's just a nice way of writing it such that we can just write I and we don't have to write 1, 2, 3, 4, 5, 6, 7, and so on. And then, yeah, so once again, this is just the same equation written down. And then this is where the person's question came in, where we say, how do we find the probability of a word given the class? So, sorry, if we have more questions about this, I will scroll back to Bayes' theorem, but I would prefer not to because it's very far behind. So, basically the probability of a given word given the class is equals to the probability of basically a way to estimate the probability of a word given a certain class is basically you find all the reviews in your database with the word W and the class C divided by all reviews of class C. So basically, for example, let's just say I want to find the probability of the word great showing up, given that the review is positive. So what I do is I find all the reviews that are positive and have the word great, and then I divide them by all positive reviews. So this is how you find the probability of each word happening. Like this is where the question kind of gets answered. So is there any other is there like do I need to
No, I think
anything?
that's fine. If
Okay.
if someone still doesn't understand, we can cover it a bit later. So yeah, do put a question in if you still don't understand, but
Yeah,
we
for sure.
might cover it later.
Yeah. Yeah, just please drop in the Q&A and then we'll go back to it if needed. So yeah, basically, so since we found P W given C, we multiply all the words in the review and then we'll get P O given C. And then, okay, this is putting everything that's happened so far together. So bear with me, okay? So C and B, which is basically the class C that naive base decides upon is once again argmax P C given O, where we say, okay, I want to select the argument C, which is positive or negative, that maximizes P class given O. And then from base theorem, we get the next part, which is P C given O. Just by moving some things around, we say it's P C multiplied by P O given C divided by P given P of O. And then once again, since O is constant regardless of C, we just say, okay, it's a constant, it doesn't matter, we're comparing these two, we're not actually finding them out. So we can just say we remove this, it's just PC multiplied by P O given C. And then once again, PC, we've already talked about how to find it. P O given C, once again, it's the probability of all these words occurring, but we assume words are independent. And then because of that, we can separate them into PW1 multiplied by C times, and then so on, so on, so on. So from here, so C and B, again, the C chosen by NB is argmax this, except we now replace PO given C with this part over here, which is just this. Okay. I hope this makes sense. It is a lot to put. It might be a lot to take in because this is referencing a lot of slides. So just to let people know, you don't need to write this down or anything. I have the link to the slides at the back of the presentation, so you guys can look at it again if you want. Yeah, so I'll just keep going. Okay, so let's try this out in practice. This is a lot of equations, so we're not going to do everything, but we're going to do a very simplified version. So let's just say we want to try out this movie was great. So let's think about this. What is the probability, just thinking about this logically, the probability that the word this would appear in a positive review is kind of equal to the probability that this would appear in a negative review, because this is a very neutral word, right? This could appear anywhere. And the same goes for movie and same goes for words. They're quite equal because, they're very neutral words. But the word great is a lot more, but the probability that great appears, given that the review is positive, is a lot more than the probability that great appears in the negative review. Because if the movie was so bad and it's a negative review, why would you say the word great? And basically, since we can see from here that if the probability of a word given C is high, this would also, this value will also increase. So basically we say that since the probability that great appears in a positive review is much higher, we say that the probability that this review is positive, given that it has the sentence, this movie was great, means that this review is most likely to be positive. And then let's try another one. So let's just say we have a review that says this movie was not good. And then once again, this movie was and not, these are all quite neutral words, right? So following our previous thing over here, we say that, oh, they're kind of the same. So these are all quite neutral words. But good is a positive word, right? So the probability that good appears in a review, given that the review is positive, is a lot bigger than the probability that good appears in a negative review, right? We can already see something going wrong here. And because of that, we can, once again, our system will once again go that, oh, because good is most likely to appear in a positive review, this thing must be positive. Which is, again, something's gone wrong. So from these two examples, here's some questions. So have we made any assumptions? Are there any limitations to our system? And have we improved from our method? What's the improvement? And are there some problems that we still haven't fixed?
Yeah,
And
so
there are questions up.
yeah, that's just gone live. So yeah, do put your answers in. So yeah, again, it's 3 questions, so it might take us a few minutes. So I'll give you some time. And I think what might be good is if we just go through some questions while we're waiting. So I will,
Yeah,
yeah,
this is great.
I'll give everyone another 20 seconds maybe. So I don't want to distract you from the questions. But after those 20 seconds, we'll have a quick look at some quick questions before we jump into this discussion.
Yeah, I think I can, oops, for a little hint for everyone, I can go back to, oops, I can go back a slide to where we have one of our case studies of where we would use the system.
And I should just say, um, if you don't have an answer for every single question, you don't have to give an answer for every question. So all of the questions are optional. So if you just want to answer one of them, that's totally fine. Just submit your answer for one of them. Um, yeah, so I can see we've got some answers coming in now. So we've got 10% of you have given an answer. So I'll give you a bit more time because I know it's quite a few questions on there. Yeah, so while you're typing your answers in, um, someone asked this question which I thought was quite interesting,
Okay.
because I don't know what the answer to it is. So when it comes to this naive Bayes system,
Mhm.
what would happen if you have reviews that have numbers in them? So, for example,
Oh.
if you had someone who rated it 1 out of 5 stars, or someone else who said, "Oh, this was a 10 out of 10," would the system then learn to associate those numbers as either positive or negative?
That's a really good question. So my answer would be, in a way, yes, but in a very roundabout way. Because our system doesn't understand the meaning of any of these words. Like if you ask, like it can only tell what good and what this and all these words mean based on previous data. So if you put in, oh, this movie was say 1 out of 5, the computer will not be able to tell like, oh, 1 out of 5 is 20%, 20% is very low, low means it's not good. It doesn't know what 1 out of 5 means. However, because how we build up our stats is from previous data, there is a chance that a lot of people would have, oops, sorry, spoilers. I still don't know how to go back. This is crazy. I'm a computer science student. But sorry. But basically, we're building up our data based on previous people's reviews, which is very important because once again, from finding out the probability of a word, we go from our database. So it's very possible that a lot of other people would have been like, oh, this movie sucks. This movie is terrible. 1 out of 5. This movie is bad. 1 out of 5. This a lot of people might have used 1 out of 5. 1 out of 5 is actually quite a relatively common phrase for people to use, right? Because we think about things in like 5 stars, for example. So because of that, there is a chance that it depends on how we allow the system to operate. Because remember how I said we sometimes have like an additional level of spell check. Some researchers might say, oh, to try to make it more accurate, like in our spell check system or in some related system, let's remove numbers so that we don't even need to think about them. But theoretically, if we let numbers come true, there is a very small chance that enough people have said that, oh, 1 out of 5 means the movie sucks, that the computer is able to calculate the probability of 1 out of 5, given that given that the review is negative, is a lot more than the probability that you say 1 out of 5 given the review is positive, right? Because you'd say 1 out of 5 only if the movie was terrible. So yeah,
Mm.
1 out of 5 and these kind of numbers could actually do something. But the problem is then how do we pass those numbers? Because people say numbers in any way. They can say 1.0 out of 5.0. They could do 1 space/space 5 rather than 1 out of 5. There are tons of ways of people saying it, which means that the chances that you actually find 1/5 might not actually be that high, even though you have tons of people saying basically the same thing. So that
Mm.
really goes into like you how you like how you extract words, which again talks about our spell check layer and all that. So I would say there are definitely ways to include and incorporate numbers. It will be very tough. And that's why, and with this kind of very naive system, it might not be very practical, but it's definitely an interesting thing to think about. Yeah.
Absolutely. And a very similar sort of, I guess, comment or question
Mhm.
was, could the system identify emojis in the text?
Yeah. And once again, if enough people use that emoji, because once again, we're going by previous reviews, yeah, it's very possible that the system could actually associate that emoticon with positive and negative. But again, because it depends on previous reviews, Then we'll talk about what if someone just randomly puts a mango and it's like, oh, this means it's positive. Obviously, the system would be like, I've never seen this before in my life, I can't tell you. And I mean, that's
Yeah,
also how a human works. Like, if you showed me, if you said, oh, I like this movie, Mango, I would probably be like, doesn't tell me anything. So yeah, it
yeah.
depends. But it's definitely very feasible.
I think, yeah. We've had quite a few of you put your answers in, about 57%. So if you are just finishing off, please do submit. And I'll do one quick question. Well, it's two questions, but I think they're very much linked. And the first question is, why do we make the assumption that each word occurs independently? And the other question is, why is it named naive? So I'll pass that over to you, Alex.
Yeah, I love that. Okay, so let me see if I can go back to our independence assumption. So we make an assumption. Each word occurs independently, which is basically saying when we say that the chance of this appearing is completely unrelated to movie, is completely unrelated to not, most importantly, and completely unrelated to good, which is not true, obviously, because once again, when we talk about words, we actually talk about them in the context of sentences. So to analyze each of them independently it's a bad assumption. It is not correct. But why do we do that is because once again, it's a way to simplify our probabilities. Once again, the probability that this movie was not good appears in any review is very low. We need to break them up into easier probabilities. It's a lot easier to find the probability of one single word rather than the probability of like 10 words. And then that goes to what are some ways we can mitigate this? Of course, we can say like, oh, maybe if the word not is seen, then we can just like, oh, like flip it, right? But the problem is then it goes into so much more complicated because a lot of people express like not is a very easy way to flip sentiment, but there are tons of other ways to flip sentiment that take a lot more words and a lot more like positions. So like, for example, one of my previous examples was I thought this movie was going to be good. There's no not in the word, but we can still tell that that means the movie was not good. But there's no really to make the computer understand that in the system that we have currently laid out for it is extremely complicated. So we can't really do that. So basically, this is
Mm.
like a simplifying assumption. Is it a correct assumption? Absolutely not.
Absolutely. And that's, I think, one of the reasons, or at least my understanding, that's one of the reasons why it's naive Bayes. It's a little bit
Right, I forgot to
naive.
address that. Yeah.
We're making an assumption that we know isn't really correct, but without that assumption, we don't have a classifier because we can't do the maths otherwise, like Alex has explained. So yeah, I just want to say thank you for everyone who submitted answers to the questions. We had loads and loads of answers. And I'm just going to really quickly sort of whiz through some of the highlights because we've actually already discussed quite a lot of this already. So, in terms of the first question, how we made any assumptions, lots of answers. So, things like we assume that negative words like not do not affect the next word. So, this is all about the fact that we've assumed that each word is independent, which we've spoken about. We've assumed words don't have more than one meaning. We assume that there's no sarcasm, so what the person is saying is exactly what they mean. Um, we're assuming that each word will either be sort of negative or positive, rather than any other sort of classes that it might have. Um, just having a look if there's anything else. Every word is treated as equally important. I think that's a really interesting one. Yeah, absolutely. And then moving on to the next question. Are there any limitations to this system? So this question is very much linked. So yeah, very, very similar answers. We're only looking at individual words. We can't detect sarcasm. Um, we can't actually identify the meaning of words, which is something that Alex spoke about. We're kind of just looking at where words appear rather than really understanding. We can't interpret context. Yeah, this is all really, really good. And then for the final question we had, have we improved from our first method? Or are there any problems we still haven't fixed? We don't need a lexicon anymore, so storage is saved. Is that right, Alex?
I think that's a complicated question about whether storage is safe because it depends on
Mm,
how many words how many words you're supporting. Because in the end, you're still storing probabilities for each word. because so that
That's
could
a good
dim a
point.
lot.
Yeah.
Yeah. Or maybe if you think about it, maybe you don't actually store these probabilities. Since you already have this data set, you can just generate them on command. But then let's think
Mm,
about that goes into like algorithm complexity versus space complexity, right? So that's a whole different, it depends on how
mm,
the systems are implemented.
definitely. This one's, I think, a really good point, is that this system is based on actual data rather than a dictionary, which is just defined by someone. So
Yeah.
this is a slight improvement.
Yeah, I think that's correct.
Absolutely. Um, Yeah, so lots of people talking about the fact that you're using probabilities as opposed to just what someone thinks of
Yeah.
words, if they're positive or negative, which is a really good point. Um, but yeah, still lots of limitations and things that we've already spoken about, I think.
Hmm.
But yeah, thank you
Yeah.
so much for your answers. Loads of really, really interesting
Yeah.
responses.
Definitely. Then I'll just keep going. So a lot of what people have said, it doesn't need someone to label it manually. You can just kind of run out the data. This is actually technically kind of wrong because when you run out the data itself does still have to be labeled. But the fact that it's still based on aggregate data, basically data from a ton of people, is still better than having a dictionary where only someone's like, oh, this is positive. Why? Because I said so. It removes bias from manual labeling. You know, maybe again, think about decent and good. Now you don't need to ask one person, you can ask a whole lot of them. Um, and I think what's really good about this one is that once again, we're talking about having words take on new meaning, having words change meaning. You don't really need to update the lexicon anymore because now there is no lexicon. Now you just need to make sure that the data that the machine learning model is running on is fresh, is new. And this is actually a very big problem in machine learning is getting the data because let's just say I trained this machine learning model on, let's say, the 1920s. Sick would have, once again, a very different meaning. But if we made sure that the data we're running this on is fresh, is up to date, and is, representative of the society as it is now, it's actually very accurate. Cons is, once again, we still assume words are independent for simplicity, so not good, it's not and good are separate. It still can't tell sarcasm, and it's a double-edged sword, You can run the machine learning on new data to keep it accurate, but then you need to do it continuously because once again, vocabulary is going to keep changing. Um, so obviously these two systems are extremely simplistic. ChatGPT, all these other things, they run on much more complicated things. A very common example of a complicated machine learning model is a neural network, which kind of models how an actual brain thinks, because how an actual brain thinks is that I think it has neurons inside with links between them. So there's many different neurons. And then as it's trained on data, it makes some links stronger and some weaker. So it once again goes by probability, where you say, oh, depending on what comes in, I might go here, I might go here. And then it tweaks those probabilities as it gets trained on more data. And basically how it works is that you put in your input data and it goes through all the neurons and it comes out there. And what is actually very interesting was someone was asking why it's called naive Bayes, right? There are actually a lot more versions of Bayes classifiers, which obviously I'm not going to go into today, but you can actually search them up. There's actually even a version of naive Bayes that's called Gaussian naive Bayes. And basically they all work on how probability works. And unfortunately, we are running out of time, so that is all of this is for next time, but it's definitely very interesting. I would highly suggest anyone who's interested to do further research. Let's move on. And yes, so our last question, well, not our last question, but our last discussion question is why did I even do this presentation? What's the use of sentiment detection?
Yeah, so that has just gone live. So yeah, please do put your answers in there. Yeah, we are unfortunately really quickly running out of time. That's because you guys have been asking some really brilliant questions in the chat. So thank you for doing that. What I will suggest, obviously, if you have to head off, that's absolutely fine. But what I might suggest is that we will stay on for another 10 minutes or so, just so that we can have a look a few more questions before we finish off. So yeah, please do put your answers in for the question, what uses does sentiment detection have? And while we're waiting for some responses, we can have a look at some of your questions and see if there are any that we can answer. So we had quite a few different questions talking about how sometimes words are neutral.
Yeah.
And for example, sometimes a whole review could be neutral. Is it possible for us using the systems that we have spoken about today to
Mhm.
create a system where we could classify reviews into those three different categories instead of just two separate ones?
For sure. So let's talk about the first one. The lexicon, extremely easy. If it's a neutral word, they just have a point value of 0. And then, we once again determine thresholds. So we say like, oh, maybe if a total score of -5 and less is negative, -5 to 5 is neutral, and 5 to onwards is positive. So that one's easy. Naive Bayes will take a bit more work, but not actually that much because um you will see that in my previous, oh my gosh, I really can't figure out how to go back on this thing. But basically in my previous slides, I talked a lot about yes. I talk a lot about C. I don't actually use the words positive and negative. I think that's a very important point to note that, I mean, of course, a lot of the times I do say like, oh, C in this case means positive and negative, just to remind you guys. But the reason why I try to use C as much as possible is because actually, it's only in this case that PC is positive and negative. We could very easily add another class that says C is neutral, right? And we would have to change our data slightly. That means in our huge data set that we're running our machine learning model, reviews now aren't only just positive or negative, they can also be neutral, right? So that would change how we have to label it. But once we have that labeled data, once we add a new class C called neutral, everything is basically the same, right? Because POC is still going to be this PC. Let's go to PC. PC is once again just going to be, so for P neutral, it would be the number of neutral reviews divided by the total number of reviews, right? So it's very easy to add new classes. In fact, if you wanted to, as long as you had the correctly labeled data, you could extend this to any number of classes. You could have, very positive, positive, neutral, very negative, negative. Um, and of course, you could extend that for like levels of nuance, right? You can say like, oh, maybe like some stuff are neutral, some stuff is very positive, some is very, very, very positive. But of course, at some points, you add too many classes and it just gets unnecessarily complicated. And it also, because the labeling might also be subjective in itself, right? Because what is the barrier between neutral and like slightly positive? So those are some questions too that really depend on research and what the people designing the model decide.
Mm,
Um, yeah.
absolutely. So what I'm going to do now is I will end the poll because I've seen over
Oh no,
50% of you have responded. Is everything all right?
yeah, sorry, my Wi-Fi just cut out, but I'm back now. Sorry.
No, no,
Is
that's absolutely fine. So I'm just ending the poll. Really, yeah, last 5 seconds if you want to submit. All right, ending it now. So we'll just have a quick look at some of your answers before diving into some more questions. Um, so one of the first answers we've got used to filter reviews from most helpful or most positive, negative. Um, Allowing companies to improve their services without having to manually read through reviews and feedback. I think that's a really, really interesting one. Um, what else have we got? Recommendation systems. I wonder if maybe Alex, you could expand on that one a bit.
yeah. So this is the wrong slide actually. Okay. Yeah, so what uses does it have? So you guys have already said, honestly, a lot of what I said. So you guys have talked about recommendations. So websites can use user behavior to figure out what they want and then use that to determine what new content to show them. So let's just say there's this guy on Facebook that's like, I love soccer. I love the game. Instantly, Facebook knows what to push this guy, right? Tons of like football things. And that's linked to advertising, where because of that, ad tech companies actually build user profiles by using what people post on the internet to determine how they feel about things. So Google, YouTube actually has tons of data on people's profiles and based on their activity has tons of information on what they like. And they sell that to companies saying that, oh, maybe this beer company, for example, is like, I want to target people in their 30s who really like sorry, football's still on my mind, who really like drinking or watching the big game. And then YouTube and Google is like, I know tons of these people. Here are the information. I can send you that. I can send them your ads. So these two kind of go hand in hand, which I think I hope is what the people were talking about in terms of recommendations and
Mm,
advertising. Um, and then lastly is generative text. So um, oops, sorry. So a lot of people will say, a lot like what ChatGPT can do nowadays is like you can actually ask ChatGPT to to use a certain tone. Like you can be like, oh, ChatGPT, please use a professional tone. Write this email to my boss. And how does ChatGPT know what a professional tone is? It doesn't understand anything. It it runs on tons of data. It can tell what people would generally say to sound professional, and it'll just spit out similar words. Like, oh, kind regards or something at the end of the thing. And I think what's really interesting about these uses is that it's very important to start thinking about ethics and security. I know there was actually a talk in the seminar series about security, and I actually don't know what was talked about then, but just to add my own take is that it's very important to think about who has this data, how it's being used. And what this means for all of us, and especially in terms of like privacy and how easily we are influenced by propaganda, because if you actually go onto Google and search, there are tons of cases where people have used this for, political gain. There have been cases in Facebook where you can actually tell someone's political affiliation depending on what they say on the platform and what they interact with, and people have actually been recorded using that in their political campaigns. Right? So it's very important to remember who has this data, how might they use it, and be safe online.
mm.
Yeah.
Absolutely. So yeah, so what I'll do now is I'll go through some of the questions we've had. Um, we've had a few that are quite closely linked together, so I'm just going to kind of bunch them together. So the first question is talking about, can the data set that you use influence the judgment and the result that you have? And sort of quite similarly, on a similar sort of wavelength, we've had two separate questions, which the first one is, could the system take into account the year that the review was written, so that it then can use that context to judge whether a word is positive or negative? And then similarly, could the model take into account how language is used in different regions, say in different countries, to make it more effective, basically?
Yeah. Okay. So before I answer these questions, just to let you guys know, to explain naive Bayes classifier in way more detail is this link. That's great. And this is basically the QR code to all the slides I've used earlier. So if you ever need to read it again or you want to see the link here, just scan this. Anyway, back to the question. So to the first question, absolutely, it is so important to take into account what data you're using into your machine learning model, because it can impact, because I mean, as we saw, it impacts your probabilities, and from your probabilities, it impacts your insights immensely. And that's actually another reason about why data is so important, like diversity in data in particular. There have been, in some cases, facial recognition software trained on machine learning models that do not work well on faces of minorities because it was not trained on that data. And that's very important, because when we think, oh, we want to create a system for everyone, we need data from everyone to train it. Um, and then to this end, because if we only have data from a certain point, so maybe data from a certain time period, that could massively affect, because once again, like, if you use data from the 1920s, the word sick is going to mean something completely different. I love this example. But anyway, and that goes into the next question: how do we mitigate this? Can we actually use this information, such as the time period or the region, to actually make our results more accurate? And the answer is yes, of course. Because I'm going to take a quick break from this slide. Basically, in machine learning models, I mentioned that we have features, which is observable properties of the data. And in this case, I gave words of text. But does it always have to be words of text? Does it just have to be words of text? No. It can be tons of things. We can take in the words of text. We can take in, the year that it was made. We can take in where the person is from. Because all of these things are things that are going to eventually affect the classes, whether it's positive or negative. Because the time period is going to affect, how they say things. The region is also going to affect how they say things. And yeah, so if we include these things as features in our model, it's very possible to use these things to generate better insights.
Mm,
It yeah.
absolutely, yeah. Thank you. I thought those were really, yeah, really interesting questions. And I think they're very, um, I guess, very linked to just what machine learning is. So yeah, it's a really good way of thinking. I guess if you're interested in machine learning, how could we make this better? And you're already sort of on the right track, basically. So I'll have a quick scan through the questions, but I think we've actually um, we've answered a fair few of them. So we've had a few questions about neural networks. So someone has asked, how much more accurate are neural networks than naive Bayes? And someone else asked, are naive Bayes classifiers used anymore?
Okay, so I'll do the first question, I guess. Neural networks, in general, generally speaking, neural networks are a lot more accurate because well, it depends because there are many types of different neural networks. It has grown immensely in the past. There are depending on the neural network, some of them can even, um, so as we can kind of see from from our current method, once you calculate the probabilities, that's kind of it. Unless you run it again on different data, the probabilities are going to remain the same. But for some neural networks, they can actually do something that's called back propagation, where um, if you have an existing neural network, but you keep running new data on it, it will actually change how it works. It can basically change its states, I guess. It can, how do I say this? It can it can receive feedback, I guess, on its performance and it can change its
Mm,
performance accordingly, depending on the really important, sorry, not really important, the really advanced neural networks. Because there's so many different neural networks, and once again, this topic has spiraled so far down. Yes, most of the time they're more accurate. And then the answers to the second question, are naive Bayes models still used anymore? And the answer is yes. And then the question is why, right? But it really depends on the use case. Because I will say for text prediction, for sentiment detection, sentiment detection is so complicated nowadays. There's so much nuance that is most likely not used anymore. But naive Bayes as a machine learning model in general is still used because of how simplistic it is. And simplest because that's when we start having a trade-off between simplicity and accuracy. The thing is, for some systems, we actually might prefer a more simple system than a more accurate system. And this might come into things like maybe, for example, like systems that need to react fast, systems that can't rely on a lot of data, or systems that, very importantly, don't have a lot of storage space or computational complexity. Um, like very interestingly, an actual um example of this is, for example, like wearable devices like Fitbit. Um, some of them run on very small chips called microcontrollers, and those things don't have the same processing power as a computer. And because of that, sometimes they need very simplistic algorithms to run on. This is just in general. This is not talking about Fitbit in particular. Please don't quote me on this for Fitbit. But basically, depending on your hardware, sometimes people actually prefer simplistic models to accuracy. So yeah, naive Bayes is still being used. Not to mention, there are so many new derivatives of naive Bayes. Once again, Gaussian naive Bayes, go look that up. There are some others that I honestly don't have off the top of my head. But if you go to scikit-learn, that is SCIKIT dash LEARN, like learn. You can see a ton of naive Bayes models on Python, Gaussian naive Bayes, multinomial naive Bayes, categorical naive Bayes. Basically, there are a ton of derivatives that work on probability and are more specific to the data. And which is why I think it's so interesting because when it comes to machine learning models, there is no one size fits all model. There is no neural network for now. Honestly, in the future, who knows? Maybe some one machine learning model will work for everything and everything forever. But most of the time, what we do with machine learning models is that we tailor it specifically to the data that's designed on. So a neural network or a machine learning model that is for text sentiment detection is not going to be the same one that they use, for example, to determine like what structures are stable, what structures are not, referencing previous talks. At least that's what I'm guessing you guys talked about. But yeah.
Perfect. So I do think unfortunately we have to finish there. Thank you so much everyone for all of your brilliant questions and just for joining us over the last few weeks. Um, yeah, just one final thing to say that I will be following up with an email um, sort of with a roundup of everything that we've covered in the seminars and also some more information about the continuation of this program if you did apply for that. So yeah, just keep an eye out for that email. And yeah, thank you so much, Alex, for the session. I really enjoyed it. And thank you everyone for coming. All right, I'll end the call now. Thank you very much. Goodbye, everyone.
Thank you, everyone. Bye.